attendees are in listen-only mode.
Welcome everyone to our NACoE Introduction to Intelligent Compaction webinar. Sorry, I was just distracted because something's come up on the screen. My name is Rosie Patterson. I'm moderating the session and I'm in Melbourne and it's windy, cold, but not wet. We've planned to go for 60 minutes with time for questions, but we'll also make the recording available for anyone who has to leave early or wants to review the webinar. We have the usual webinar functions, so please type your questions into the question box, and we love your input. We have a very large audience today, 709 people registered, and we've got people joining as we speak and building the numbers, so exciting. Our presenters today are Dr. George Chang and Dr. Jeffrey Lee. Welcome, George. How are you? Where are you?
Howdy. I'm from Texas.
Howdy is Texas. Howdy is howdy a Texas word. How are you?
I'm fine. I should say good evening here and good day in Australia.
Awesome. Yes. And welcome, Dr. Jeffrey Lee. How are you? Where are you?
Hi, Rosemary. I'm in Brisbane, Australia. Hi, George. How are you doing in US?
It's nice and hot here.
Is it? I think you two know each other, hey?
Just about 20 years.
Well, I'll just quickly tell our audience a little bit about you both, but you've got such massive bios, we can't get through them all today. And Dr. George Chang is recognised as the expert for pavement, smoothness and intelligent compaction construction technologies. And his research work has been featured in over 50 professional publications and 100 plus reports. And Jeffrey will tell you, our audience, a little bit more about you in a minute. And Dr. Lee is a principal pavement engineer at ARRB and has more than 19 years of experience in the areas of pavement materials and non-destructive testing for major transport infrastructure projects. And he has authored over 20 research publications. So welcome to you both. Welcome to our audience. And I think, Jeffrey, you're going to start us off.
Yes. Okay. Thanks a lot, Rosemary. Again, thank you everyone for attending this webinar, and great turnout. I guess this webinar, right? Its title is Introduction to Intelligent Compaction. What triggered this is that this year, as part of the NACoE, which is a National Asset Center of Excellence research program, a research initiative between Transport and Main Road Queensland and ARRB. I'm being tasked to look into the evaluation and implementation of this intelligent compaction, and this webinar is a outreach program to get everyone to be more familiar with this technology. So this 60-minute webinar, right? Where we're going to be, you'll be hearing from me and George in turn. This is the rough outline of what we're going to talk about. First, I'm going to talk about the scope of the NACoE P105, which is this intelligent compaction project, and give you a bit of background. And then George is going into more specific details, like an intro to what is intelligent compaction. I think for the rest of this webinar, we will just call it IC. In early June, right? Actually, this NACoE project is has the great pleasure to invite George Chang coming over to Southeast Queensland to deliver a 2-day workshop for us. And I'll give some basic about the field demo and as well as the workshops, and then that leads to the serve as an introduction. And George will just tell us what the data that has been analyzed. So with that, then we'll go to Q&A, and I'm sure everyone will be super excited about this project, just as passionate as I am. And then I'll wrap it up at the end. So yep. So again, this is the background and scope of the NACoE 105. If we go to the next slide, please. As I mentioned earlier, right, this project is sponsored by the NACoE research initiative between TMR and ARRB. This is going to be a multi-year project, and we are just at the start of this. Yes, next slide. So a bit of background to everyone, right? I'm sure a lot of the attendees will already aware of IC, but in short, intelligent compaction or IC has been, it's not a new technology. It has been used worldwide for the last at least 15 years. And what it does is basically, right, is incorporating some response sensors, a survey grade GPS, and an onboard display on our common roller compactors that we use in construction site. And with those technology being fitted, right, it will be able to give us, for example, like a pass count of our rollers and giving us what is the response of the compacted layers. And I guess for asphalt applications, we will be also monitoring the temperature profile, which is essential to when we are compacting asphalt materials. I guess also one of the major benefit of this is that with the onboard display, this technology is really assisting the roller operator to achieve uniformity and minimizing over compactions. A lot of the time, when we keep on having the roller rolling past the layer, sometimes I have to say, more doesn't necessarily the better. And I guess with uniformities and all these measures of how well we are compacting the layers, it will improve the construction efficiency, which is the major benefit. And a second benefit is that all this data, right? Nowadays there's a it can be stored in the cloud, and it would be readily available after construction, so anyone can be reviewing it. And like I say earlier, PO 105 is sponsored by TMR and ARRB as part of NACoE, and we began in January 2019, and I'm pleased to report that we have gone a long way in the last 6 months for this multi-year project. Yes, next slide, please. So with that, I'll pass it to the Texan. Yep, George, here you go.
Howdy again. So I'll give you a kind of background about intelligent compaction before we get into what we have done earlier this month for the IC workshop and field demo. So IC was called Continuous Compaction Control, CCC. It was invented about 1978, 40 years ago. We just celebrated 40th anniversary of CCC last year in Vienna, in Austria. So as Jeffrey just mentioned, this is a technology by instrumenting the vibratory roller with several key components and make it not just a construction equipment, but also a measurement equipment during construction. This is just an innovative invention at that time, not waiting until the compaction is done and do the measurement, but to measure it during construction so you can adjust it as you go. As you can see from here, one of the key components is on the top, the GNSS GPA receiver that will help to track the roller passes and pass count. And with the temperature sensor mounted, then you can measure the same temperature, surface temperature for asphalt compaction. The core technology is the one that mounted mostly on the center of the front drum. It's a cerometer to measure the stiffness of the material. We're going to get into more detail later on what this cerometer has been measuring. So what this IC can do for is so-called the real-time feedback to show the roller passes and the temperature as well as the stiffness of the material on the onboard display, so it can provide a real-time feedback. One of the key difference between the conventional spot test and the intelligent compaction is the coverage. For the footprint that normally just 1/1 of using the spot test to conduct QC as well as assurance acceptance test, is really a very limited way to measure and not really representative for the entire area for compaction. So intelligent compaction can cover 100% of the compacted area. We're going to show you how it can do and provide you the information. When IC was invented about 1978 and on, for the next 20 years, IC or CCC, continuous compaction control, is normally being used for the single drum CC roller for soil and sub-base compaction. So IC have been started to be used for asphalt compaction in the last 20 years. The slow development is because a lot of models have to be simplified in order to build in to the IC roller to measure the stiffness of the material. And that's what is shown on the screen here. You can see the roller have been showing on top and compacting on the asphalt layer, and the asphalt layer is sitting on top the sub-base and subgrade. So the drum have been enlarged on the left corner here is the roller drum, and the ceramic have been mounted on the axle of the roller drum. What it does is to measure the rebound signal when the roller drum is in vibration mode. When the compacted material and the compaction force and reacting force will be received and measured by the accelerometer. Then it will feed into the control system and calculate so-called ICMV. That stands for a generic term for intelligent compaction measurement values. So the box control system is showing in the middle is the so-called black box that all the models from a roller and the compacted material had to be solved in order to give you the matrix. So that turned into a various different measurement metrics, so-called ICMV, for different type of solutions. One of the key earlier solution is called the CMV, compaction meter value, on the upper left corner. And then that was a model that using the frequency ratio to calculate the matrix. So that ICMV, such as CMV, can be related to the in situ test, such as Plato test, that turn into a stiffness value. And that this so-called level 1, which is the first generation of ICMV. Later on, it's been evolved to several different variety. One such is called CCV, compaction control values. That's invented by that Sakai from Japan. It's just a variety from the CMV values. And later on, HMV have been used for HAM from Germany, and those are still so-called the level 1 ICMV, which is based on the frequency ratio from the signal of the measure. Later on, there are several different levels of ICMV being invented, including the level 2, which is not showing here. It's called machine drive power, MDP. That's based on power index. And the level 3 is the next generation. It's called EVI on the upper right corner. That's a vibration modulus. And also in the left corner here is another EVI from BOMAC and also being used by Dynapec. And the KB value also so-called soil stiffness value from a Mount case from Switzerland. That's a level 3. And also a Chinese solution called CPMS VCV value. That's a level 3. Then what we're looking for is the next level, level 4 and level 5, which is already in the market or will be in down the future. In 2017, 2 years ago, Federal Highway had published an ICMV roadmap that detail all these different models to solve the ICMV value to reflect to the level of compaction, starting from the level 1, 2, 3, 4, and ultimately to level 5. I'm going to talk about more level 5 ICMV later in the session. So that's kind of delineate the evolution of the ICMV development in the past 40 years. In terms of industry solutions, there's several double drum IC roller available in the market, including those from Bormac on the left, and the middle is the one from Han, and on the right, upper right corner is Dynapec. On the left, lower left corner is Caterpillar, and the middle low part is a Sakai, and the right one corner is from Volvo. So those are the double drum IC roller for asphalt compaction. There are also one single drum IC roller for soil compaction. You can see from here on the upper left here is from Amman case from Switzerland, and also work with the American company called Case. And Caterpillar have also one single drum IC roller, Han, Bormac, Dynapec, and Sakai. Sakai have a very unique single drum IC roller, which is smooth drum roller with the padfoot shell kit. So just about 7 years ago, there are one new product just came out to meet the market demand. This is so-called the IC retrofit. So instead of buying or purchasing those OEM machine from what we just saw from a single drum or double drum IC roller manufacturer, users now can buy so-called IC retrofit kit that can be mounted on the existing roller, such as the one showing on this slide here, that including the GPS receiver, the accelerometer that can be mounted on the front drum of the roller, and also the infrared temperature sensor mounted on the front, as well as the rear drum. And they also include the onboard display. And they also have connected side gateway from several solution provider that can beam their data to the cloud to make the data transmission and sharing much easier. There are a lot of science and technology behind it, and I'm going to show you how it can benefit you for single drum IC roller compaction for soil and double drum for asphalt. So this slide shows a snapshot of the stiffness of the IC map from after pass number 1, 2, 3, all the way to pass number 8. So this is from one of our IC demo project in Texas a while ago, and that was compacted using a double drum or single drum padfoot roller from Amman case. And you can see from here the color-coded map been showing the low value in red. And when you increase the stiffness of the material, then it will change to yellow and green and darker value. You can see from here, just looking at the differences between the different passes, it shows the progression of the stiffness of material being increased after each roller passes. And when you plotted this value, so-called stiffness value versus the roller passes, this so-called the compaction curve. When we saw this in snapshot during the field demo, we noticed that the 1/3 area, there's one red spot cannot be compacted, and this turned out to be a soft spot. And when we went over there, it turned out to be places where they have more than 15% over the optimum moisture content. So when the soil moisture is over so much, over the optimum moisture content, you cannot really compact it. The solution is use an IC roller to identify those areas and then till it out and also and dry it out and then recompact it when it drop down to the moisture, optimum moisture content. Next is so-called the pre-mapping. Prior to 2008, there's no such concept of pre-mapping. What we did for this project was in Minnesota in 2008 is to use, before the double drum IC roller being used for the asphalt compaction, we use the same roller was setting to low frequency and low amplitude for vibration, and using the roller to map or simply draw to pass, do one pass measurement run. Some people may call it proofing run, to measure the existing granular base, subbase, before placing the asphalt layer. You can see from here on the left-hand side, we have shown you the map, the pre-mapping subbase stiffness map. This is using the Sakai CCV value. Remember, Sakai CCV is called the compaction control value. It's similar to what we just saw earlier for the KB value from amount case. We coded the color in red, its signal is a low value. And when you turn to yellow and blue, it's a higher value. You can see from here, both comparing the subbase map and asphalt map, the support, which is the weak support area, had reflected from the subbase map to the edge, to the asphalt map. So what happened to the second day of the paving is we noticed an asphalt truck had been paving on the northbound side. When it drove off the southbound side, you can see from here, it tore off the asphalt that had been paved the day before. So that premature failure is only 1 day old. You can see my pen that I put it on the enlarged area, and that's showing that it basically it just the stiffness material asphalt just not enough, and the compaction have not done correct properly, and they just tear it off. As it turned out, those area is happen to be over the soft spot, which is the subbase, have some problem. When this subbase been compacted the 6 months before, it was accepted by the nuclear density test. However, the material under the subbase had a lot of organic material and peat material that caused a very soft spot in this area. When put another lift of asphalt for compaction, it just not be able to sustain the kind of support and to achieve the compaction. So this premature failure was have draw a lot of attention, and later on, pre-mapping on the existing subbase material have been very popular ever since 2008. And later on, Caltrans, California Transportation Department of Transportation, have been mandated to use pre-mapping for all their full depth repair projects. So this is sort of the blind test that we conducted in Indiana at one of our IC demo tests. So what we did is, this is a map, sort of roller passes map. One pass is the red, second pass is yellow, and the third pass is blue. So that shows how consistent the roller pass is. So the before is when we cover the display and asked the roller operator simply just those 3 passes. And the contractor happened to pick the best roller operator for the blind test. And later on, the second day, we have trained the roller operator how to use the display by uncover the display and show how that roller, the color-coded map can guide the roller operator to do a better job. And showing up, when we show the before and after roller passes, this has shown immense improvement over just for a brief training. So really 2 things we like to achieve with continuous compaction control and intelligent compaction is consistency and uniformity. And that will really will improve the quality of the pavement and make the pavement lasting longer. Up to you, Jeffrey.
Okay, thank you, George. Yeah, I really enjoy that video that you play. It basically shows what IC technologies is all about. I guess with me, I'm going to touch on about this IC workshop that was held on 3rd to 4th of June over in Southeast Queensland here. Next, George, please. Yeah, so this is the ICDM workshop. This is one of the marketing brochures that we put out. For those that is not familiar with the ICDM workshop, it basically stands short for Intelligent Compaction Data Management Workshop. So there's two parts to this workshop, right? First is like a classroom presentation that we have, just for the Australian audience as well, this ICDM workshop has actually been delivered by Dr. George Chang and his team for the last 12 years. So this one is actually the first that is being delivered in this format in Australia. So we are very lucky to have that happen. And like I say, in the day one, right? This is basically it's like classroom hands-on workshop. So we'll cover we have covered the IC basics, and then we have go through like this Veda software, which is a software that has been used a lot to manage and analyze all these IC data. So we have the participant to go through it on their laptop, and then on the second day, that's when we have run a field demonstration trial. As you have seen from the previous slides from George, I mean, in US and in other parts of the world, IC technology has been used, on real jobs. So, I think when I'm looking at this NACoE project, we are looking into, how can we leverage all this experience that's already happening in overseas and accelerate the implementation in Australia. Okay, next slide, please. So this is the happy snapshot that I had. This is the day one, and I'm not sure if you see, in the middle that there is Dr. George Chang speaking to our participant. The participant at that workshop was mainly transport and main road staff, as well as some local government representatives and other different parties. I guess I have to apologize for not being able to being able to cater a larger group of audience. You would appreciate that, with all this hands-on experience, so on, we can't have a larger group, but that doesn't mean that we can't be organizing more of this ICDM workshop in the future. Next slide, George. So on second day, right, to make things really interesting, at the end of the day, we are looking at a construction problem. So with partnership with Civil, we actually identify a industrial development site where we are going to have a set up different strips of earthwork general field materials, and we have this roller fitted with the IC kit to collect some data and demonstrate how easy this process can be. Next slide. And at the start, we have a briefing demo to advise the participant, what exactly we are going to observe. And I happen to pick the day that is the coldest in Brisbane to be having all the participants out in the wide open. So anyway, that was a good experience. Next slide. And again, we are using a Dynapack smooth drum rollers. Next slide. And to top it off, right, I guess with this IC roller, we are doing getting the response from the accelerometer and having the visual feedback inside the cabinet in the roller compactor. But as an additional add-on, we are doing some spot testing, across this site, and then one of the machine that we use was the lightweight deflectometer, which is basically you drop this dead weight on the ground, and then it gives you a response from deflections to indicate the stiffness of the ground. Next slide. And again, this is another view of the Dynapack, and we have fitted a Trimble IC retrofit kit. And as George has mentioned, right, sometimes the IC technology can come with as an OEM solutions, or it can be a retrofit kit. And this is the one that we use on site. Next. And this, a close-up shot of you will see the mounted in the center of the drum, and where the cursor is pointing. This is the accelerometer, and to me, that's is one of the essential technology that we are using to monitor the motions. Just bear in mind, when we are adopting this technology, because we are measuring the vibration of the drum, make sure that accelerometer is mounted in the correct positions. Next, please. And with that, right, we basically have a trial area that is 60 meter by 20 meter. It doesn't have to be very big, and to be able to provide a large contrast, what we are doing is breaking this area into 3 different parts, and they are all prepared at different moisture content. As seen here, one is at OMC, one is at optimal moisture content -2%. And next slide, we also got a wet area that is OMC plus 2%, as shown in the next slide. Yep. And then next, please, George. Again, another photo of the ground that we are operating, and the participant actually were able to climb up to the cabinet and see the IC roller after it's being parked. Next.
Jeffrey, this is George. Did you remember the contractor had buried a tire in the test strip?
Yes. Interestingly, right? To keep things interesting rather than just changing the moisture content, we went to a little bit of a treasure hunt. So actually, we would not know where a buried truck tire was, and George will show you later on how well the IC technology works to identify it. Yep. And again, this is just what the roller operator will be seeing. On the right, you can see the color map that shows the coverage and all the CMV values that is getting. Next slide. Again, with all this onboard display, you have the pass count, the speed, and CMV values, and it's quite very intuitive, and to me, I think, and then that's also the experience from the US as well, that it's very useful information for the operator. Next. And for those that would like to keep an eye on how things are happening in the field, VisionLink is a software from Trimble. That is just the Trimble solutions, and you can log into the using your different IT gadgets and your phone as well. I would suggest not to do that when your partner is next to you when having a vacation. But anyway, next. And again, this is a photo of the lightweight deflectometer that is being used. Next.
Would you like to take some questions before the next topic?
Maybe we will keep that at the end, Rosemary, and I'll pass that to George, right?
Okay,
yep.
No worries.
Thank you.
All right. So here's the fun part. The data from the IC are telematic. At first, it's stored locally and telematic and transmitted to the cloud. And then you can export it using different software. And then you can import to the standard software called Veda. Veda is a standard software we developed for the Federal Highway of the United States and a lot of the DOTs. And it's now required by the national standard ARRB. And we'll show you in a minute how to correlate all the analysis. So Veda is a free public domain software. And we recently have upgraded so that now it can be used in Australia and New Zealand by using the MGA and also New Zealand map projection. Here I'm showing the Veda's screenshot of the unfiltered data, which is raw from the roller. And you can see the data been sitting right at on top of the satellite map. Here's is an enlarged map of pass count on three different areas. And we can do analysis to show the pass count, frequency, amplitude, speed, as well as the CME value. So, and you can also view the speed map. So it's showing how fast the roller been running. And you can also do the analysis as a histogram. Here's the frequency part. So for this analysis, for this test strip, we're using the constant frequency. And here's the amplitude map that during the test strip, the roller arbiter changed different frequency. As you can see here, if it's distinct here. And the analysis showed the two different distribution, which are corresponding to different frequency. Here's the very interesting plot that you can see on the top. There's a red spot. That's where the moisture content is 2% higher than the OMC. And the middle part is the OMC. On the left-hand side, that's the OMC with 2% less the OMC. The red spot here is a soft spot where the treasure hunt that Jeffrey mentioned about. That's where the contractor had buried a tire underneath, but been detected by the IC roller. So this is the analysis. And during the test, during this test strip, there were LWD tests being tested on different spots, showing the spot, the black dot over here. Each of the black dots have been also measured with the handheld rover to measure the position. So those data can be imported and put into Veda and do the correlation analysis. When the three different moisture content zones have been lumped together, the correlation between the Trimble CMV and the layer moduli from LWD has not been very well correlated. But if we were start to filter the data, in this case, it's filter data to three different zones, such as the OMC plus 2%, it can be easily done using Veda software. So the powerful feature in Veda is to filter the data any way you want. So the OMC plus 2% have been filtered out, and the correlation is not good. And that's consistent with a lot of study and recent study been done by Sakai and Japan, that when the soil and is in above the optimum moisture content, there's no correlation between the CMV and stiffness value and the layer moduli. And here's where the OMC minus 2%, and what I'm showing here is where the buried tire is being detected by the ICMV stiffness value. So when you do the correlation between the Trimble's CMV or ICMV value versus a layer moduli from LWD just for the OMC minus 2%, we got a very good correlation here. This is better than most of the correlation we've seen in the past. The OMC area also can be extracted and also correlate with the ICMV from Trimble. And in here, the correlation is if the R squares is over 0.5, and that's R square R value greater than 0.7. This is a universal accepted correlation for the test strip. They've been used in most of the spec in the US, in China, as well in Europe. So with this correlation, you can base on your acceptance layer moduli to look up the value for the target CMV for compaction. Another way to do the target ICMV is to use Veda to analyze the IC data. In this case, is OMC area, optimum moisture content area with the LWD spot test. In this case, it's compaction curve. So the Veda will average the mean value for ICMV after each road passes. You can see the progression of the CMV value increased after first pass at about 26 and increased after second pass to 32, and then level off after 5 passes. In this case, you can set the target CMV value and then determine the target roller passes. Then the rest are the strength of IC is to use the color-coded map on the real-time display to guide the roller compaction operation to achieve your target roller passes with a uniform coverage.
Goodness me, that was massive. Thank you. Are you ready for some questions? You're right. So I'll ask a couple for you, George, and some for Jeffrey. Is that what we're thinking?
Sure.
Yes, sure.
So the first one for you, George, how does the accelerator keep sense of air voids in the surface?
Can you say that again?
The accelerometer, the accelerometer keeping track of the air void in the surface.
Yeah, it does not. What does ICMV value for the accelerometer is track the stiffness value, not the air void. As for the ICMV, level 1, 2, and 3 cannot track the air void. And what we're looking for is using higher dynamic analysis model developed for the level 4 and level 5 ICMV, which is detailed in my article published for the Federal Highway IC roadmap. And that will provide you both the moduli and air void, which is a density value. So that's upcoming in the level 5 ICMV.
Thank you. And Matthew has asked Jeffrey a question regarding decision-making from the data collection. The analysis has been undertaken of the input to asphalt compaction being undertaken. For example, the controlled input, including design mix. Is that, have I asked that clearly, or shall I send it to IT?
Well, I guess I'll have answer to that. At the moment, my understanding is with the IC technology, well, the first, the most obvious advantage is to measure the pass count and then having a good record of the temperature profile. And as I mentioned earlier in the webinar, these two are key aspects. I think with the evaluating using the IC to determine the thing, the stiffness as well as the density and so on, having a higher level of IC equipment would be more essential. George, do you have anything to add to that?
Yes, let me chime in a little bit. So year 2012, we have conducted so-called the ICMV value to correlate with the asphalt in-place density. What we have found is for level 1 to ICMV value, the correlation between ICMV and the in-place density is very low. As you know, they've been based on so-called the frequency ratio method and the energy index. However, over the many tests that we have conducted, during the breakdown compaction, even though ICMV value does not measure the air void and density, it does have a correlation with the density growth curve, which is compaction curve for the density is similar or in phase with the ICMV value. We have a lot of publication in those studies. So what we're looking for, as I mentioned about, is to raise the ICMV to the level 4 and 5. Then it can produce and give you an index both for correlating to both modulus and also density.
Thank you. And William has asked, what limitations do you foresee compacting sensitive cohesive soils that do not respond that well to vibratory compaction?
Yeah, this has been a difficult subject. What we have found in our past study is for the so such a material, the accelerometer-based ICMV may not be adequate. So what solution that industry have provided is from Caterpillar proprietary solution. It's called machine dry power, NDP, that can measure the ICMV value in static mode, which is ideal for such application. Then again, most of the compaction for clay material have to be using the pivot or roller to have a kneading compaction. And then what we recommended is when the pivot compaction is close to the end, when it walked out, then you can use the smooth drum IC roller to do the mapping approving run.
And Deborah asks, how useful is this technology when stabilizing small patches with a polymer?
That would be a very limited application. For small patch, keep in mind though, the ICME value be measured across the drum. The drum size about 2 meters wide. So for a small, very localized area, it's difficult to detect.
And Leon is asking, Jeffrey, why IC is not adopted more rapidly in Australia?
Well, I guess, like I say, that this project started in January 2019, and we are working on that. I think I'll leave it at that.
Awesome. Brendan has asked, has sampling frequencies increased with improving technology since the introduction of IC?
The sampling frequency in terms of a spot test or the IC itself?
Not sure. Brendan can write and add to that if you like. Jeffrey, did you want to add to that?
Yeah, I guess my response is, as mentioned earlier, right? IC actually providing 100% coverage, and I think it is a real advantage from the current practice. Rather than relying on an unlimited number of say the density measurements and so on. So I guess IC technology, right, and some of these other in situ modulus testing, which I was also the project leader on under another NACoE project. We are all working into how can we increase our reliability of measurements, and being able to do the in situ stiffness measurement, and then being able to provide the feedback in a timely or in this IC technology case, instantaneous feedback to to assist in construction decision that needs to be made.
Let me chime in a little bit. Based on what we observe for the application of IC, especially on large projects, when the project has started to evolve and building a confidence between the correlation of ICMV value versus spot test, what the owner have made decision is to reduce the spot test. One such example is during our workshop, a BOMAG have shown Istanbul airport project when they require more than 1,000 spot tests for a given day, that have been reduced to less than just a couple dozen tests for a given day, because the ICMV value can provide such a coverage and measurement.
Well, we've just got a few minutes to finish up and close off. One comment from Brian, pretty cool innovations and monitoring efforts, guys. Hopefully the Australian governments will learn more about this and be willing to spend additional costs. And one from Sutha, George and Jeff, can you please provide any comparison of gains in dollar value?
I think in the Australian context, right? Because we are trying to look into this technology. We haven't got those dollar number yet. I guess in the US that there may be some number. George, is it right?
Yes, we do. I have tracked hundreds of projects using IC in the past 10 years. What we have observed is the IC cost compared with the construction cost is about less than 1%. Less than 1%. So it's a very minute investment, but the effect and the benefit is humongous. It's just the consistency and uniformity that we just show you some of the examples, and several hundred projects we have observed over the past 10 years in US do show the benefit of return of investment.
Awesome. Well, we'll move on to finish off your final key messages and closing slides, and to let people know that we will send a link to the recording of the video of the webinar so that you can revisit it, and we'll talk about that towards the end. So please stay on the line as we finish up, as well as Jeffrey and George have asked for any information about further training. But let's move on to our closing slides. Thank you, George.
Okay, so I know there's a lot to take in this webinar, and trust me about that, and we have provided a lot of information. So what happened is I have prepared a sort of a technical brief, and it's now published on the NACoE website. You can find the link below. Basically, it gives a quick summary of what this PO 105 project is, and you know, the ICDM workshops, and a lot of the graphs that George and myself would have presented. So feel free to you know, go to the web link and download it, and send it to all your friends, and you know, yeah, we can go from there. And I guess a bit of a closing remark from my end. I think we have established that, you know, that this IC technology has been used worldwide, right? You know, that there's no doubt about that, and I think we just need to try that you know, a bit more in Australia, and here's my contact, you know, and I guess if you want to talk about ICDM workshop, or if you want to venture into some of these demo field trials, you know, to give me a call. You know, I'm only you know, a phone call away, and we'll get back to you. George, anything to add?
Yeah, please contact Jeffrey so you can bring it back to Australia again.
Oh, George, with that, right? We have to mention that you are coming back to Australia in August. Yes,
I'll be giving a keynote speech on intelligent compaction. Surprise. At the AAPA International ARRB Conference in Sydney. So I look forward to see you there.
Fantastic. Yep. Thank you very much. Anything to finish up with, Jeffrey?
No, like I say, you know, I think the technology has been proven overseas. We just need to get into it, and I'm speaking from my experience at the field demo. It's actually not that difficult, so let's try it out, you know, and see it for ourselves.
Awesome. And we will get back to any unanswered questions. Thank you to our audience for sending them in. It's been great. George and Jeffrey, talk soon.
Thank you.
Thank you all for the audience.